Hallo zusammen und herzlich willkommen zu einem neuen Video aus
Hello everyone and welcome to our new video, this time in a totally different setting. I'm here at the University of Applied Sciences in Aachen, where I'll be visiting the Aerospace Engineering department with a very special mission. Today, we'll be testing our latest model in accordance with the DIN 8330 standard for pilot watches. In order to receive this certification, our new watch must pass a variety of tests with extremely specific requirements. In a minute, we'll discover how it all works and which tests need to be passed with success. I'm here in the first testing lab, where the first tests are about to begin. I have, of course, enlisted the help of an expert. Robert Plante, a research assistant at the University of Applied Sciences here in Aachen, will be accompanying me today. Hi, Robert. Come introduce yourself.
Hi.
So, feel free to fill us in. What are we going to witness today?
Well, it's pretty common knowledge that airplanes must withstand extreme levels of stress and pressure. These same requirements also apply to pilot watches, which must be certified by the standard DIN 8330. The tests that we'll be doing in our lab today were created in accordance with this standard.
Which tests will we do first?
Die erste Prüfung, die wir anschauen, ist die Zentrifuge. Das heißt,
First up is the centrifuge test. In this test, a centrifugal force of 6G is applied for an entire minute to determine whether or not the watch becomes damaged or disintegrates.
lose oder feste Teile sich lösen.
Okay, should we start up the machine? Here we go! The DIN standard requires that the watch be placed in several positions and subjected to a centrifugal force of 6G. In total, the watch is tested in 3 different positions for 1 minute each. We've shortened the total duration of the test for the video.
Was wir hier sehen, ist unsere Zeitwaage. Das ist einer unserer
This is our time accuracy test. It is one of our most basic tests, which is performed before and after every mechanical test. We can also listen to the test. You can actually hear the movement, which helps predict the accuracy of the watch, or the number of seconds by which the watch is off after a day.
Wie viele Sekunden die Uhr nach einem Tag Zeitversatz hat. Mit diesem Gerät, was wir hier sehen, wird die Dichtigkeitsprüfung
This
durchgeführt.
device is used to perform a pressure test. This test is repeated after every mechanical test. We put the watch in the chamber, fill the chamber with pressure, and measure the deformation of the crystal. After a certain time, the device indicates whether or not the watch has passed the test.
A sudden drop in pressure in the cabin or cockpit can affect the inside of the watch, causing the crystal to pop out or mechanical components to become jammed. During this test, the pressure is reduced from 752 millibars to 44 millibars within 15 seconds. A diagram makes it possible to track the test values and the differences in pressure.
Next up is the hazardous material test. Certain fluids are used in the aviation industry to operate airplanes. Pilot watches must therefore be able to withstand these fluids. For example, kerosene and diesel. We place the individual watch components in the fluids, then remove them 24 hours later to ensure they are still in perfect condition. This is our oven, which can reach high temperatures as well as sub-zero temperatures. These temperature fluctuations are common in aviation, which is why we simulate them with this oven. First, we'll set the oven to 55 degrees Celsius. Then, the watches are placed inside and the temperature is lowered to minus 15 degrees Celsius. after which time the watches are inspected to ensure that they are still in perfect condition. This is especially important as large fluctuations in temperatures can cause the various components and their materials inside the case to expand at different rates, thereby potentially affecting the overall functionality of the watch.
So, wir haben jetzt einmal das
So,
Prüflabor
we are now in a different lab where we'll be performing vibration tests. There's a lot of heavy equipment for such a small watch. What's in store next?
Well, this here is our shaker, which we'll use for our vibration tests. During any flight, any number of vibrations can occur. That means the pilot, as well as the watch, are exposed to different frequencies. And these frequencies are simulated here. The vibrations alternate between 2 Hz and 10 Hz in 2-minute intervals, and after the test, the watch is checked to make sure it's still working properly.
Then let the vibrations begin.
Here we go.
Vor der Prüfung der Stand- bzw. Vibration.
Before testing the stability or vibration resistance of the watch, the simulator and the corresponding measuring and testing equipment are set up and calibrated with precision. Afterwards, the watch is attached. The vibrations of the shaker change continuously and pass through different frequencies that are scrupulously defined and described in the standard procedure.
So, wir sind jetzt bei der letzten und härtesten Prüfung.
We are now ready for the last and hardest test, the impact test, which is set up in such a way so that our poor test watch will lie here and receive a mighty blow from this super heavy metal hammer. I'm going to give it a try now.
Und ich teste das Ganze jetzt schon mal.
Light to medium impacts can be enough to damage or permanently impair the movement of even a good mechanical wristwatch. In a moment, our watch will be struck at a speed of around 4.5 meters per second.
Von etwa 4,5 Meter pro Sekunde mit dem Hammer weggeschleudert.
So now I'm curious to see what happened to the watch. As you saw, that was quite a blow. Robert, could you bring me the watch, please? Let's take a look here.
Gemeinsam drauf, danke.
Thank you. Yes, I'd say the watch is still intact and running. Impact test a success.